All right, so let's take a look at our next example and graph this piecewise function. So this function is split up into two parts. F of x equals to 2x if x is less than 1, and f of x is equal to 1 half x plus 4 if x is greater than or equal to 1. So the first part, it says, to graph a piecewise function, make a table for each of the domains. So I made two different tables. Why do I have two tables? Because I have one function is 2x, which is this one, and another one is y equals 1 half x plus 4. So make a table for each function. Okay? If the domain includes a start and ending value, then use both points in your table. And then part 3 is graph by plotting the points. So here's the thing. When you make a table, you have to pick your x values. Okay, now which x values do I pick? So if you look at this function, f of x equals 2x, this function exists only if x is less than 1. Okay, it only exists if x is less than 1. So the x values you pick, they have to fall in that domain, x less than 1. Now here's kind of the thing that always tends to raise some concerns with students. If x is less than 1, why do I have to start with 1? Here's why. Because if you start with 0, then you're missing all the points between 1 and 0. You're missing point 1, point 2, point 3, point 4, point 5, point 6, point 7, point 8, point 9. All those are less than 1. So to account for all those points, you still have to start at 1. But the difference is that you're going to put an open circle on that when you graph it. Okay, so if you use x equals 1, then 2x is 2 times 1, which is 2. If x equals to 2, then you're going to get 2 times 2, which is 4. Oh, wait. Am I going the right direction? I'm not, because what does my domain say? X has to be less than 1. So I'm going the wrong way. I want to pick all the values of x that are less than 1. So I can't do this, but I can go to 0. Because I'm picking x values that are less than 1. So if this is 0, 2 times 0 is going to be 0. What else can I pick? I can pick negative 1. 2 times negative 1 is going to be negative 2. So it's important that you understand why we're picking 1, 0, and negative 1, because your x values have to be less than 1. So they can be 0, they can be negative 1, you can pick negative 2. 2 times negative 2 is negative 4. Okay, and when you graph this, at 1, you're going to put an open circle. And I remind myself of that by putting an open circle on 1. Okay, now let's go to the right table. For the right table, we're going to use y equals to 1 half x plus 4 if x is greater than or equal to 1. Okay, if x is greater than or equal to 1, we're going to use this function. So what are the values of x we pick? Well, again, you always start with the boundary point. So I'm going to start with the 1. Now I want values of x that are greater than or equal to 1. So I can pick 2, I can pick 3, I can pick 4. And because there's an equal to sign, this is going to be a closed circle. And I denote a closed circle using a bracket. So to remind myself that when I graph it, I'm going to use a closed circle for that. So let's plug in x equals 1. If I plug in x equals 1, I get 1 half times x, which is 1 half times 1 plus 4. Well, 1 half is like 0.5, and 0.5 plus 4 is going to be 4.5. So at 1, my y value is 4.5. Okay, what about at 2? 1 half times 2 is just 1, and then 1 plus 4 is 5. So this will give me 5. Here, I get 1 half times 3, which is 1.5. 1.5 plus 4 is going to be 5.5. Then my next x value is going to be 4. 1 half times 4 is 2. Half of 4 is 2. 2 plus 4 is 6. So my next y value is going to be 6. So I'm using this function, but I'm only using values of x that are 1 or greater, because that's what this says. For x greater than or equal to 1, you would use this function. So the key point to this is to make two tables, and when you make those two tables, make sure you always start with the boundary point, which is 1 and 1. 1 and 1. In the first function, you pick values of x that are less than 1, because it's x less than 1. In the second one, you pick greater than or equal to 1, so you pick values that are greater than 1. Okay, now let's graph both these functions. First one, so you graph them individually on the same graph. Our starting point is 1, 2. So I got 1, 2, and I reminded myself I have an open circle, so I'm going to put an open circle there. Then I have 0, 0, then I have negative 1, negative 2, and then I have negative 2, negative 4. So it's going to look like this. Now notice that my line only goes this way because this domain says x has to be less than 1. So this table is valid only if x is less than 1. All right, now, what if x is greater than or equal to 1? Then my first point is 1 comma 4.5. So here, I got 1, 1, 2, 3, 4, and 4.5 is going to be somewhere in between that. This time I put a closed circle because I have an equal to sign on the 1. And I provided myself that with a bracket. That's going to be a closed circle. Then I have 2 comma 5, so that's 1, 2, 3, 4, 5. Then I have 3 comma 5.5. And then I have 4 comma 6, so it's going to look like this. All right, so that's a graph. You take your table, you take the table, translate that into a graph. At this point, if you're still not sure about what's going on here, it's fine. Like I said, it usually takes students some time to understand piecewise functions, but you will. So I want you to get a basic idea of what they are and then come to class prepared with questions. The last thing we're going to do is we're going to find the domain and the range of this function. Now remember, the domain is all the possible x values on the function. So let's take a look at this. This domain is x less than 1, and this is x greater than or equal to 1. So that means that here, every x value to the left of 1 is covered because x less than 1. That means 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. They're all going to be covered. Then on this side, x greater than or equal to 1. So starting at 1, all the values are covered, like 1, 2, 3, 4, they all have y values. So the domain is just negative to positive infinity. All the x's are covered. This function covers everything to the left of 1. This function covers everything 1 and greater. So your domain is going to be negative infinity to infinity. All the x values are covered. Now the range, that's your y values. So remember, for domain and range, you're looking for the lowest and the highest. Lowest y value and the highest y value. So this little arrow tells you that this line is going to keep going this way forever in the negative direction. So on the lower side, your range is, this is going to go to negative infinity. So on the lower side, you have negative infinity. Now it keeps going, keeps going, keeps going, and guess what? It stops there. It stops at y equals 2. This is y equals 1, y equals 2. This graph stops here. So this first graph, it only is going to go until 2. And because we have an open circle, I'm going to use a parentheses. Then at 3, at 4, there are the y values. So I have to put a u because there's a gap in the y values. Then the y values, they start up again here. They start up again at 4.5. Because this is 4, this is 5, in between that, remember we had this value is 4.5 as for the y value. So the y values start up again at 4.5, and then they keep going to infinity. So on this side, it's going to be 4.5 comma infinity. So that's your range. Okay, the y values, they go from negative infinity to positive 2, they stop, so you put a u. Anytime there's a gap, anytime there's a break in the y values or x values, you put a u. Then the y values start up again at 4.5, and they're going to go to infinity. Okay, and that's your domain, and that's your range. Again, if you're confused about this, that's totally fine. Just come to class prepared with some questions that you can ask. But I recommend that you go back and you watch the video again and try to learn as much as you can before you come to class.